Any command starting with SDFS, okay, DFS-ls, okay. Any command starting with SDFS. Understood, guys? Huh? Okay. Any command starting with SDFS, okay, so that will be like
storage command.
storage layer command. Any command starting with yarn, okay, so the command itself will tell you, okay, this is a yarn command. Understood? Any command starting with yarn, that will be given to resource manager. Any command starting with SDFS, that will be given to node. Understood? Okay. So you will identify storage layer commands and processing layer commands. Okay. So here, okay, you run any command, any processing layer command, okay, that command will be handed over to resource manager first. Okay. Resource manager is the first point of contact for your command. Understood? Okay. And it keeps track of all the node managers using simple heartbeat mechanism. Okay. So every node manager, once the service is started, each and every node manager will be sending heartbeat to resource manager. Okay, so what resource manager will do? Okay, so in this heartbeat, okay, each name node will send information like, okay, what are the total resources available, what are the user resources, what are the allocated resources for yarn, what are the total resources, allocated resources for yarn. And normally it will not tell the total resources actually. Okay, so it will tell you instead of total course, okay, allocated course. Understood? Allocated course, user course, and free course. Allocated RAM. Understood? Okay, so here, whenever a node manager is started, okay, immediately it will start sending the heartbeat to resource manager for every 3 seconds. In that heartbeat, it will send information like, so my allocation, my yarn allocation is 6 cores to 26 GB RAM, 26 cores 26 GB, 6 core 26 GB. So like this information will be passed to resource manager. Okay, and resource manager will store all this information into a file which is called as a cluster state store. Okay, so at any point of time, resource manager will have a clear picture that, okay, what are the allocated resources, what are the allocated RAM, allocated cores, and what is allocated RAM, what are the user cores and user RAM, okay, what are the free cores and free RAM. Okay, so at any point of time, okay, resource manager will have this information. Are you clear? Are you clear, guys? Okay, so the next one. Okay, it maintains the cluster state store. Okay, this is the cluster state store. Information about each node manager. That is called cluster state. It maintains the application state store also. Okay, what do you mean of application state store? So here, okay. Normally, if it is a Hadoop command, okay, so let's say if it is a SDFS command, SDFS, DFS, hyphen, less and all. So normally all SDFS commands will not take too much time to complete. Yes or no? Because okay, just seeing the content on what to say, content on your HDFS or files on your HDFS or project directories on HDFS. You are just seeing this information, or you may be copying a file from one place to other place like this. So HDFS commands will not take much time to execute. Okay, but when it comes to yarn command, okay. So if you run a job, okay, if you run a job, obviously at times, okay, if it is if you are running a job on small data, it may take only 2 minutes time, 3 minutes time. Okay, but what in case if you are running a job on, what to say, on, okay, 1 TB data, obviously that will take a lot of time. Yes or no? Okay, so there is no guarantee that, okay, your processing layer command will be completed or your job will be completed in 2 minutes or 3 minutes. At times, okay, it may go for one day also. You are running a job on 100 TB data. Okay, who knows? Your program may run continuously for one day, and after one day it will give you the result. Yes or no? Correct? Okay, that is the reason. Okay, for each and every processing layer command, since you know that it takes a lot of time, So you will be okay. Every processing layer for every processing layer commands. Okay, to track the processing layer commands. Okay, what RM will do as soon as somebody submit a job. Okay, it will give a job ID or application ID. Understood? Okay, so track. Okay, so this is the ID given for Venkata's job. Okay, this is the ID given for Venu's job. This is the ID given for Ravi's job. This is the ID given for Rani's job. Okay, what is the status of Venkata's job? What is the status of Venu's job? What is the status of Ravi's job, Rani's job? Like this, okay, it will be maintained the status of each job also. Understood? Okay, so after that, okay. So it handles application master records. Okay. Instruct node manager to launch application master container when the new application is submitted. Okay. So what is this new application master, guys? What is this new application master? What is this new application master? Okay. So we will do one thing again. We'll come back to this part after some time. Okay. Now we will go to node manager part actually. I will talk about application master also later. Okay. So what is the node manager? Now, okay. So node manager is a service, is a worker service which is running on slave service or worker service in the ARM framework and runs on each data node. Normally, so node manager will be running on each data node. Okay. So what is the work of this node manager? It provides the information to RM through heartbeat on total allocated available resources. Okay, are allocated used and available resources. Understood? Okay. So the total resources means okay, total given to YARN. What is allocated means given to containers. What is available means free resources. Okay, so resources means okay, both CPU and RAM and status of running containers. Okay, so as at this moment you don't know what is container and all. Okay, okay. So what is that? You don't know. Okay, and takes care of launching or releasing execution of a container based on the instructions from RM. Okay, so what node manager will do, it will take care of launching, releasing, execution of containers based on instructions from RM. Okay. So if RM says that, okay, hey, launch a container, it will launch a container. Release a container, it will release a container. Execute a container, it will execute a container. Okay. Based on the instructions from RM and kills runaway containers when required. Okay. So fine. We will do one thing. Okay. So let us start with a job. Okay. What will happen? What exactly happen when you submit a job? Okay, when you submit a job. Okay, think like this, guys. Okay, so let's say I have a file sample.txt. Okay, when I put this file into Hadoop, okay, when I put this file into Hadoop, okay, so how it will go? It will go in the form of blocks, right? That okay, I have 50 MB file. Okay, when I copy this file into Hadoop, where it will be copied? It will be copied in the data nodes. Yes or no? Yes or no, guys?
Yes, sir.
Let's do one. Let's take a copy of this one. Okay. This is my cluster, guys. This is my cluster. Okay. I'm removing these heartbeats and all to make you understand. Okay. You can this one. Okay. Okay, sir. So now you take a file, okay? So a sample.txt file. Okay. The size of this file is 50 MB size. Okay. So this sample.txt file will be stored in Hadoop. Tell me, guys.
In HDFs,
In SDFS, okay. Yeah, SDFS okay, it will be stored, right? Okay. So let's say the sample.txt file is divided into BLK 001, BLK 000. Is it fine? Now we are storing this one with replication factor 3. Okay. So BLK 001 is here, here, here. Okay. And BLK 002 is here, here, okay, here, and here. Is it fine? Yes or no, yes?
Yes, sir.
Okay. So this is how your blocks are stored in different data nodes. Okay. Any questions till now? Any questions till now? This is how blocks are stored in the data nodes. Okay. Okay. So now there is a requirement, guys. There is a requirement. Okay. What is the requirement? This is the sample.txt file. I want to know. Okay. This is my requirement. Okay. How many times word do repeated in this file in sample.txt? What is my requirement, guys? What is my requirement? How many times a word Hadoop repeated in the sample.txt file? Okay. So how you do this one? So in a traditional process, okay. So if it is a traditional process, what in a traditional way, how will you do it?
Control F.
Huh? No. Okay. So you will write a program. Okay. So normally, okay. So in a traditional way, you will write a word count dot jar file. Okay. Word count dot jar file inside this one. Okay. Normally, how do you find a word, guys? Okay. Normally, okay. If I ask you, okay, sir, I will do one thing. Okay. I will do one thing. Okay. Um, I'll take simple examples actually. Okay, I'll take simple examples. Before we go into the sir, this is a small fruit box to which you have. This is a small fruit box which we have. Okay. Now I'm asking you, try to understand, guys. Okay. If you understand, okay, how you are doing this process, okay, you will understand. You will understand processing layer today itself. Understood?
Okay, sir.
Understood? Okay.
Sir,
So there is a small fruit box. Okay. Small fruit box. Okay. I've asked you to count, okay, how many apples we have in this. In this. How many apples we have in this box. Okay. So this is what my requirements are. Okay. I have given you this work. What you will do. What you will do.
we will search apples and we will count one by one.
First, what work you will do?
First, we will segregate or split, sir.
Separate all the apples.
Okay. So this is the box. Correct or not? This is the box. Okay. Now, okay, at the end, okay, so I have the box with multiple fruits here. I have the box with multiple fruits. Okay. Now I want, okay, so what is my output? Okay, input is box of fruit box. Okay, what is my expected output? Count of apples. This is my expected output. Okay. So now, if I ask you this work, what is your approach? Tell me.
Separate all the apples and then count number of apples.
Okay, don't use two technical things. Okay, I'm asking you a real life. I mean, okay, in real life, what you will do. I'm not asking you to give a technical uh, result or technical approach, because okay, see, Hadoop is completely built on our human activities. Okay, if you know your human activities, okay, you will know Hadoop. Okay, so now normally, okay, suppose, okay, if I give this okay, to a kid, see, we know programs, technical, okay, technology, so many things. Okay, kids doesn't know that, right? Kids don't know that. Okay, you are giving this fruit box to your kid. Okay, so which is a 4 years kid, let's say. Okay, he doesn't know any technology now. Okay, apart from YouTube. Okay, so how he will do it? If you say, so first actually what you will do, you will start okay, separating the apples itself. Yes or no?
Yes, sir.
So from here, first what you will do from here, okay, you will do something. Okay, so what you will do something, what you will do here, okay, you will segregate all apples. Yes or no?
Yes, sir.
You segregate all apples. Okay, first, okay, you will put all the apples aside. After that, what you will do?
We'll start count.
What you will
Count the apples.
now you tell me. Hmm? What you will do? First, okay, you will do the segregation. Correct or not? So first, okay, you will separate all the apples into in one place. After that, you will put them into one place. Okay, now you will count. You will do the segregation. Finally, you will get the count. Yes or no? Yes or no, guys?
Yes, sir.
Yes, sir.
Okay. Or okay, maybe okay, I can take it like this. Okay, so Like this you will segregate. Okay, finally you will give the count here. Okay, so finally you are saying that okay, so we have count of apples. Okay, so now you will say that okay, I have 20 apples in the box. Sir, 20 apples. Will you agree with me? Will you agree for this process?
Counting the apples is a consolidation, sir.
Of course, yes, right?
Yeah.
Yes or no? Counting the apples means okay, you're consolidating the apples actually. You're consolidating the apples. You're putting all apples in one place. Okay, first, okay, you are segregating all the apples into one place. Okay, from here, okay, now you are counting it. Okay, this one you count it. Okay, now you got your output. Okay, now you are giving output like 20 apples. Will you agree with me? This is what you will do normally. Correct. First, okay, you will do the consolidation, you will do the segregation. Okay, whatever you want, you will segregate first. Okay, after that, you will do the consolidation. Correct. Correct or not?
Yes, sir.
Okay. So now this is a small box. Okay. What in case if I give you a very big box? What big box? What you will do? What you will do?
Same.
Same, right? Obviously same. Okay, you will do the same. Okay. You will do the even it is big box also. First, okay, you will start the segregation. Then you will do the consolidation. Maybe okay. Here, okay, you will get like okay, instead of okay, 10 apples, okay, you may get 100 apples. You will say. Correct or not? The work is same. Okay. Here, okay, so 1 kg fruits. Okay, let's say okay, 5 kg fruits. Okay, kg box. Okay. So here 20 kg box. Even 20 kg box also you will follow the same process. 5 kg box also you will follow the same process. Will you agree with me?
Yes, sir.
Yes, sir.
Process is same. Okay. Maybe time may vary. To check 25 kg box, okay, it may take only 5 minutes. Okay, 20 kg box, it may take 10 minutes. Only that time will change. Okay. But now, in case if I give you, okay, so here, okay, time also I will write 5 kg box, okay, time 5 minutes. Okay, so here, time 20 kg box, okay, 20 minutes. Okay, 20 minutes, okay, I've taken. Okay, now, okay, now you have, okay, you can have 200 kg box, right? Now this time we have 200 kg box, very big box. What you will do? What you will do, guys?
Same. Segregation.
Obviously same. Obviously same. Okay. Obviously you will perform the same operation here also. Okay. Maybe finally you will tell okay in 200 kg box, you will tell 1000 apples, but it may take 200 minutes. Okay. So in this scenario, okay, how many people okay you are using to do this activity? You are getting in all the 3 scenarios, you are getting the output, correct? Correct or not?
Yes, sir. Yes, sir.
But how many people you are using here?
Person.
Only one person.
Only one person. Okay, so only one person is doing this work, and okay, he's taking 5 minutes. Here also only one person is doing this work, and he is taking 20 minutes. Here also is okay. Only one person is working here, and okay, and taking 200 minutes. Okay, huh? Clear, guys?
Yes, sir.
Okay. So now, okay, okay, okay. Got a okay, lorry fruits. Okay, so 2 tons, 2000 kg. 2000 kg fruits. Now Now, what you will do?
If one person, it will take one more time.
Okay, suppose, okay, if it is a traditional way, obviously you will do the same process even here also, okay. But okay, for him, okay, he will take 2000 minutes. Okay, maybe, okay, 20,000 minutes. Okay, so 20,000 minutes, okay, so okay, these many kg fruits, okay, so these many minutes, okay. But do you think, okay, one person can do this one? Huh?
No.
Do you think one person can count, okay, 20,000 kg, it means 20 tons. Huh? See,
No.
if one person do this one, okay, this process is same. Yes or no? Process is same, but you may get, okay, more and more apples. Okay, but at the end of the day, process is same. Here also, it is the process is same. Okay, but do you think? Do you think? Okay, this can be done by single person? Hmm?
No.
Definitely, this cannot be done by a single person. Okay, even, okay, if you stretch also, okay, working to 20,000 minutes continuously means, okay, 20,000 divided by 60. How many hours? 333 hours divided by 24. It means 13 days, okay, you should count continuously without stopping. Yes or no?
Yes, sir.
By the time he count, okay, everything will be spoiled also. Okay, it means, okay, I would say, okay, can I say this is impossible?
No, sir. Possible.
Huh?
Yes, sir. Impossible.
Possible, but okay, worse. Okay, so
It takes time.
it takes a lot of time. Okay, so since okay, and by the time, okay, you do it, okay, all the apples may get spoiled also, right? 13 days,
Yes,
okay, if you keep all the apples in one place, okay, all the fruits in one place, okay, they'll get spoiled, right?
yes.
It is waste.
Even
Ah,
he also.
it is waste. Okay, so can I say that this is, okay, waste? This is impossible. Can I say counting? Even though you wish to count, okay, by the time you count, everything will be spoiled. Correct.
Yes, sir.
Okay. So, okay, all these days, okay, so this is traditional processing days. What do you mean of traditional processing here? Okay, whatever is your input, okay, only one person is working. Okay, so here one person, here also one person only. Here also one person, here also one person. So possible. Yes or no? This is possible. This is also possible. Okay. This is possible. This is impossible. Impossible. Okay. So here also we are doing this one. So wherever you use, okay, one person is a traditional way, guys. That is traditional way of doing things. Okay. Whatever is the work, only one core will take care of that complete work. Okay. But I want to achieve this one, sir. I want to make this possible. What you will do? What you will do? First of all, okay. I'm saying 2 tons, 20 tons, 20 tons fruits. Okay? 20 tons fruits means, okay. So do you think there will be a, 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 a box which can hold 20 tons? So max, okay, 100 kg, 200 kg. Okay, even if you try, okay, you may get. Yes or no?
Yes, sir.
Okay. But do you think, okay, there will be a box, okay, which can hold 20 tons in one box? First of all, you cannot put 20 tons in one box. Yes or no? Yes or no, guys?
Yes, sir.
Fruits in one box. You will not have any box box okay, to hold okay, 20 tons of fruits. Okay. So, but okay, if I don't have box to put okay, 20 tons fruits in one place, how they will give me 20 tons fruits if I ask? Okay. So these 20 ton fruits, okay, they will not give like a single box. Okay. So they will say, this is your 20 ton fruits. Okay. But I am giving you these 20 ton fruits. Okay. In small box. Understood? Understood, guys? Okay. Understood. Okay. Like this. Okay. So this is my entire okay, entire 20 tons fruits. Okay. They are giving me like this actually. Okay. So how many boxes they are giving? Okay, maybe this is okay. Small box one. Box one. Okay. 100 kg. Box two. 100 kg. Okay. Box three. 100 kg. Okay. Box 200. 100 kg. Okay. So is this possible?
Yes, sir. Possible.
This is possible, right?
Yes.
Okay. So it means okay. So 20 ton fruits okay, are not coming like a single box here. 20 ton fruits are not coming like a single box. Okay. So if I want 20 ton fruits, okay, we don't have any box to put in one place. So that is the reason we are dividing the 20 ton fruits into pieces, 100 kg pieces, and putting into different fruit boxes. Okay. So now, okay, if all the, I mean, what is the size of all these small boxes?
20 tons.
20 tons. Okay. Now I'm asking you to do this one. Tell me, how will you do it? Now, what is my requirement? What is my output, expected output? Okay. Count of apples. What you will do?
Allocate each box to a single person.
So I'm asking you to do. I'm asking you to do. Okay. First of all, okay, can you alone do this one? First of all, can you alone do this one?
No, sir.
The same problem okay we had, right? Okay, 20 ton fruits. Okay, if I want to do it alone, okay, then okay, it will take 13 days. Okay, 13.5 days. Okay? By the time I complete this one, okay, all the fruits will be spoiled. Correct or not?
Yes, sir.
Okay. So now, okay, this cannot be done by single person. Okay, if you do okay one by one, okay, one box up one after other. Okay, see, doing this one okay at a time or doing okay each box one after other also, it is the same thing.
That's same.
Same thing. Okay. So now what I will do, I'm giving you, I'm saying that okay, hey, okay, so I will take Barney. Okay, hey Barney, okay, so I'm giving you this activity. If you want to, you take people. Actually, I'm fine, but okay, I'm giving you the leadership to you. Okay, okay, I'm giving the ownership to you. Okay, so here Barney is the leader. I'm asking, okay, so Venkata is asking Barney, or Venkata is giving the responsibility do this activity to Bharani. Okay. So what Bharani will do? How Bharani will think now? Tell me, sir. If I give you this activity, okay, what is your approach? Definitely, it cannot be done by Bharani alone. First of all, yes or no?
Yes, correct.
Okay. So Bharani needs some people.
Yes, sir.
Yes or no? Bharani needs some people. Okay. So now the question is that how many people he needs? Huh?
4.
Sorry. See how many boxes we have total? 200 boxes we have. Yes or no? Total 200 boxes we have. Okay. So shall I take like this? Okay. So Bharani is taking, okay, asking, okay, so is taking 200 people. that he is taking 200 people, sir. Is it fine?
Fine.
Huh?
Yes, sir.
Okay.
He is taking 200 people. Okay. What? Okay. He will take 200 people and he will tell 200 people what he will tell.
To count the number of apples.
So which operation okay he will do to perform?
First segregation and
Okay. So it means okay. Can I give both the work to the okay? So let's say okay, person one come here. Person one okay, Bharani handed over to person one. Say that okay, hey person one okay. So this is your box. So you count it and let me know apples. Okay. Suppose okay, he is counting this box and finally okay, he is telling that okay, hey Bharani okay, I have okay only 100 apples inside this one. Is it the final count or okay? Only partial count.
Partial.
Count of apples in this box.
Only one box is partial.
Okay, only one box means it's a partial count.
Yes, sir.
Okay. So it means okay. So now what all these 200 people will do? What Bharani will do? Bharani will tell all these 200 people. Okay. Okay. So let's say Venkata is telling Bharani to do this one. Now Bharani is checking. Okay. First of all, checking. Okay. So okay, 200 boxes we have. Okay. Now Bharani is coming back and asking Venkata, hey. Okay. So do one thing. Okay. Give me 200 people. I will do this one. Understand? What Bharani is doing, okay. Bharani is asking Venkata, okay, hey Venkata, give me 200 people, I will do this one. Okay?
yes.
So now who is giving 200 people now?
Venkata will arrange
Venkata
the
is
people.
giving 200 people to Bharani. Sir, first okay, Venkata came to Bharani and told, okay, do this activity. Okay? What Bharani is doing now? Bharani first okay is okay checking how many boxes we have, okay, how many people we have. He is doing the estimation. Yes or no?
Yes.
Okay. After doing the estimation, okay, so Bharani is going back and saying, Venkata, hey Venkata, to do this activity, I need 200 people. Give me 200 people. Okay. So now Venkata will give 200 people. Okay. Venkata has given 200 people. Okay. Then each person. Okay. So person one, here person two. Yes or no? Person three, person four. Okay. Person 200. Yes or no? Okay. What Bharani will tell now? What Bharani will tell to this each person?
Count the number of
Count the
apples in your box.
Will he say okay, count or segregate?
Segregate.
So he will just say that hey, okay, from each box you segregate. Understood? He will just say segregate. He will not ask okay to do consolidation because okay, even though if you say do consolidation, is it the final output? Is it the final output, guys? So they are
Segregation is
segregating.
the final output.
Okay. So now, okay, so all 200 people, okay, started working on these boxes. Okay, they segregated the apples. Yes or no? Okay, so these people work is just segregation. Yes or no? Now, who will do the consolidation? What is consolidation? So
Counting the
now
apples.
these people work is completed now. So you are using separate
Bharani.
set of people, segregation people. Now Bharani, okay, will Bharani do it? Bharani is kind of a managing person here, right?
Managing. Okay.
Managing person. Yes or no? So Bharani is not doing anything actually. So Bharani is saying that okay, he's estimating the work and asking for the people. Okay. So Bharani estimated the work and asked for the people. Okay. So how many people he asked? 200 people. So Venkata said, okay, go ahead and take 200 people and start your work. Okay. So now these 200 people will take one box and they will do the segregation part. Okay. Now again Venkata will go. Okay. So this is segregation. Yes or no? For segregation, okay, so Barney is asking, I want 200 people. Okay. Now I need to consolidate it also. I need to consolidate. Okay. But for consolidation, we require again people, right? Yes or no? So now he is asking, okay,
Yes, sir.
I have only one fruit to consolidate. Okay, I will say again, okay. Barney is going to ask, okay, hey, Venkata, can you give me one person for consolidation? Understood? So for this consolidation person, okay, what is the input? These segregated apples are the inputs. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Okay. So now, okay, what these people will do? He will take all these apples and okay, he'll now he will count all these apples. Okay. So he will say counting. Okay. So here 2 lakh apples. This is called as
Sir, then also it will take time because one person is.
okay, 1 second, sir. 1 second, sir. 1 second. This is consolidation. Okay. Consolidation. Okay. Okay. Now you take the same thing here. Okay. Okay. If I go with this model, it is taken 13.5 days. Yes or no? But okay, if I take 13.5 days, okay, it is okay. By the time okay, I count, okay, all the foods will be spoiled, and there is no use of that count also. So maybe after 4-5 days itself, okay, you can continue your counting. Correct? Correct. But here, okay, so now you are using 200 people. 200 people. Okay. How much time each person will take, guys? Here? How much time each person will take? See, earlier, okay, think that, okay, so for 5 kg box, okay, it's taking 5 minutes, okay? It's taking 4 minutes for segregation. Okay? Consolidation equal to 1 minute.
$16.
Tell me.
$16.
Consolidation?
4 minutes.
4 minutes.
Okay. In this scenario?
160
160
and
minutes.
40 minutes.
In this scenario? Huh? Tell me.
1600. 16,000.
Yes or no?
4,000.
Will you agree with me?
Yes.
Okay. Now, how much time? How 20 kg segregation? How much time it will take? 100 kg segregation. How much time it will take? Guys? Huh?
80 days, sir.
First time. Minutes. Okay. So now 80 minutes. Okay. See here, one question. Here. Okay. When person one is counting box one. Okay. Is there any problem for person two to wait? Okay. Person two also can work parallelly.
Yes.
Yes, sir. Parallelly, he will work.
Huh?
Parallelly, he will work.
Parallelly he can go, right? When
Yes,
person
sir.
one is working, why he has to wait for person two? Why? Okay. Is there a reason person to wait for until completion of person one? No need. If 80, okay, if I have 200 people, all 200 people can start their work at the same time. Correct?
Yes, sir. Yes, sir.
Correct or not? Okay.
Yes, sir.
So it means, okay, if they start at the same time, how much time they will take, okay, for the segregation? Total time
80
segregation.
minutes, everyone.
So total time for into
80 minutes.
80 minutes. Okay. 80 minutes. Okay. So now, okay, now let's talk about consolidation. Okay. If 200 kg consolidation is taking 40 minutes, okay, 100 kg consolidation will take how much time?
20 minutes. 20 minutes.
20 minutes. Okay. So think that, okay, so sign for segregation here. Okay. Sign for consolidation. Okay. Okay, it is taking, okay, since we have 200 boxes, okay, and one person is doing this one. Okay, let us take, okay, 200 into 4 to 4, 8 minutes, 800 minutes consolidation. Okay, so now what is the total time here? What is the total time here, guys?
880 minutes.
880.
Eighty minutes means how many? How much time?
37 hours.
Good, very. Okay. I get to call 200 people plus, okay, one person at a time. Okay. How much time I'm taking? Time for segregation, like 80 minutes. Okay. Time for consolidation, 800 minutes. Okay. So total time taken is how much? How much, sir? So, see, Barney is coming and asking me, saying that, okay, Venkat, I need 200 people to do the segregation, one person to the consolidation. Okay. So, if I'm able to provide all 201 people here, okay, 201 people here, okay, at a time, so Barney will be able to complete the counting work in 83 minutes. Yes or no? Yes or no, guys?
Yes, sir.
Okay. So this, okay, so here. So he'll be able to complete in 15 minutes. Okay. Venkata can provide 200 people, 201 people at a time. Okay, Barney can complete this work in 200 minutes. Okay. But what in case Venkata doesn't have 200 people, sir? Okay. So Barney is asking, sir, okay, I want 200 people for segregation and consolidation, one person. Okay. But Venkata is telling, hey, Barney, I don't have so many people, but I will give you 100 people for segregation and okay, one person for consolidation I'll give you. Okay. So if I give 100 people for segregation and one person for consolidation, if I tell like this, how much time Barney will take to complete this work? First of all, can Barney complete this work with 100 people? Huh? So if you are Barney, how will you think? Okay, I'm giving a see, you have 200 small boxes. Yes or no? Okay. So you're asking me to give 200 people, but I told, okay, no, I don't have 200 people. I have only 100 people. Okay, you do the counting with 100 people only. Okay. Now tell me how Barney will do the counting with 100 people.
So one person will do first box, then he will go for second box.
Okay, so it means, okay, so first what Barney will do, he has 100 people, right? He has 100 people. Okay, what he will do? How many boxes he has? How many people he has?
200 boxes.
200 boxes, sir.
So
200
each
boxes,
person
100
will,
people, right? Okay, so in this scenario, what he will do? First, okay, he will tell 100 people, hey guys, first, okay, you start counting 1 to 100 boxes. Yes or no? He will do batch by batch. Yes or no?
yes.
Yes or no, sir?
Yes.
So first, okay, so 100 people are there, 200 boxes are there. Okay, first, okay. So for person 1, you'll give box 1, person 2, box 2, person 100, box 100. It means, okay, so for all 100 people, he has given work. Okay, so now how much time they will take to complete this work? 100 boxes. All people, okay,
18
work
minutes.
parallelly, they will complete in 80 minutes. Yes or no?
Yes.
Yes.
Yes, sir.
It means like the first set of boxes are completed. Now, the same 100 people can Barney use to do the second counting. Huh?
Yes, sir. Yes, sir.
So, okay, work is completed for 100 people. Now they are ideal. Now they are asking the same 100 people to go for one more iteration.
Yes, sir.
So again, person 1 will take 101 box. Person 2 will take 102 box. Okay, person 100 will take 200 box. Yes or no?
Yes.
It means, okay, again, okay, if they work parallelly in the second iteration, again it will take 80 minutes. Yes or no?
Yes.
Yes.
It means how much time it is taking with 100 people, how much time it is taking?
160.
60 minutes, okay. But consolidation is okay. In the previous scenario, also one person, here also one person, 800. So, if we go like this, how many hours it will take? Tell me. If we go with 100 people, okay, and 100 people for segregation and one person for consolidation, how many hours Barney will take to complete this activity? Huh? So 200 SP segregation people, one consolidation. Okay. S people, 3%. Okay. Now tell me. Tell me guys. Okay. So is it fine now? 16 hours. Okay. What in case if Venkata says that, okay, hey, Barani, okay, Barani is asking, okay, sir, I want 200 people. But okay, Venkata is saying that, okay, hey, no, Barani, okay, I can give you only, okay, 50 people, 50 segregation people and 1 consolidation person. Then what will happen? What will
For
happen?
segregation, 180.
Huh? It will go in 4 batches. Or no?
320.
Guys. First 50
Yes, sir.
boxes, okay, first iteration. The same 50 people again take second 50 boxes. Okay. The same 50 people will take third 50 boxes. Same 50 people will take fourth 50 boxes. Okay. So for each iteration, it is taking 80 minutes. So total time taken is 320 minutes. Okay. And okay, consolidation is 1 person. It is same. So what is the total time taken here? How many hours they will take? If Barney get 50 people only, okay, how many hours he will take to do the counting?
19.
Huh?
19 hours.
19 hours. Okay. Suppose, okay, if Venkata give only 25 people, then how many iterations it will go? 25 people means
6
8 iterations.
6 minutes.
8 iterations. Okay. So how many hours it will take? Venkata get, okay. So Venkata has given to Barani that, okay, he is asking 200 people, but Venkata is telling, hey, no, I don't have 200 people. Okay, I have only 10 people to segregate. Okay, okay, start your count with 10 people. How much time it will take? 10 people means how many iterations it will go?
20.
20 iterations, right? 200 by 10. Okay, into each iteration 80 minutes.
16.
How many hours? 40 hours.
40
Okay?
hours.
So if you give only one segregation person, tell me, sir. Venkata give only one segregation person, one consolidation person.
200 iteration.
Okay, here we thought that it is 4,000 seconds, right? 4,000 minutes, right? But why we are saying 800 here? Now you see, sir. What is happening? If we give only one segregation person, it is equivalent to traditional processing, right?
Traditional person.
Yes or no?
Yes, sir. Yes, sir.
Which is equivalent to our traditional processing. Okay. So where is 2.83 days? Where is 68 hours? Okay, 2.83 days. Where is 13.92 days? Correct or not?
Yeah, correct.
Okay. So now when you do your one work with multiple people, this is called as, okay. So the last, okay, traditional model. Okay. Only one person for, this is the traditional model, sir. Understood? Segregation plus counting will be done by only one person. Him also same. Yes or no?
Yes, sir. The last one is traditional only.
This is the last one is traditional. Okay. So here, okay, but okay, here, okay, you can say I have 2 people, right? But end of the day, can you start the consolidation without segregation?
No.
No, right? Okay. In this scenario, So one person will do the segregation, one person will do the consolidation, but one after other. But here also same person is doing, okay, first segregation, then consolidation. Okay, both the scenarios are same, but here I am using two people.
Yes,
Here I am
correct.
using one person. Okay, so in this scenario, this is better than this. Yes or no? Here wasting one extra person. Yes or no? There is no parallelism here, right?
Yes, sir, correct.
Okay, this is waste process. Understood, sir? Understood?
Yes, sir.
Okay. So now, okay. Now in this process, who are all involved here, guys? In this process, who are all involved? Any questions here, guys? So when you will complete your work, when you will complete your work faster, when you have more and more people. Okay.
So sir,
But can I have 400 people here, guys? Can I have 400 people?
No.
No. Okay. See, one box cannot be counted by two people. Yes or no?
Sir.
Okay. One box cannot be counted by 200 people. Okay. So now tell me, who are all involved in this activity? First of all, okay. So the main total fruits. Okay. Half 20 tons. Yes or no? This is total fruit. Okay. Total fruit. Okay. Total set of fruits. Total set of fruits. 20 tons. Okay. But this 20 tons is in one box or 100 multiple boxes?
Multiple box.
Is divided into small boxes
Each one 100 kg.
of 100 kg. Yes or no? Okay. Yes or no, guys?
Yes, sir.
Okay. Now who are all there? Venkata is here. Venkata is here. Okay. So then Bharani is here. Yes or no? Bharani is here. Okay. Then who else is there? Segregation people are there.
Consolidation.
Consolidation people are there. So who are all involved in this work? That's what I'm saying. Who are all involved in this work? Fruits are involved, right?
Yes.
Yes, box.
Small boxes are involved,
Yes.
right? Okay. Venkata is involved.
Yes, sir.
Bharani is involved.
Yes.
Segregation people are involved. Consolidation people are involved. Okay. So now, if I put all these things into a technical words, into yarn, okay, this is called as a file. Okay. Understand, sir? Small blocks are means okay. Blocks. That's all no.
Yes, sir.
Okay. How many file blocks? Okay. If you have 100 GB, you'll get 80 blocks. So we'll go 20 tons. Okay. So 200 boxes, right? 200 boxes means 200 into 80 blocks. Okay. 20 GB means how many blocks? Okay. GB 8 blocks. Okay. 25 GB. Okay, sir. So Venkata. Sir, I'm putting the same work into Yan. Okay. 20 times fruits is nothing but your main file. Small boxes are nothing but your blocks, file blocks. Okay. Venkata is a resource manager. Bharani is application master. Mapper is a segregation person. Reducer is a consolidation person. Understood? So now, okay, let us go technically. Guys, okay, any questions till now, guys? Any questions till now?
So, sir, this is the explanation of the our yarn, right?
Exactly. How? Okay, see.
Because I don't see too much, time. Still, there is too much time consumption, but in Hadoop it is like very less time consumption, right, sir?
Okay, but normally, okay. So suppose, okay. So this is okay. 2.83 days.
Are better
Okay.
than
So
yours.
if it is a for human, yes or no?
Correct. Sir.
But if I give this work to robo,
Yeah, it will be more faster. Yeah, correct, sir.
understand?
Yes.
Okay. Yeah. Okay. See here. Okay. Try to understand. Okay, whether my time is getting reduced or not.
Yes, sir. It is reduced. Yes.
Okay. That you try to understand. Okay. See, if I go alone, okay, it is taking 13-14 days. Okay. So it is coming to 2.83 days. Okay. How much we are saving here? How much we are saving, sir?
Almost 10 days.
Almost 10 times, right?
10 times. Yes, sir.
10 days. Okay. 5 times I'm saving. 5 times I'm saving the work. Or not. So it means, okay, 400% efficient. This is 400% efficient than, or 500% efficient than this one, this work. Yes or no? If you do it in 1 hour, this will do in 10 minutes. There's a difference between 1 hour and 10 minutes, right? If
Yes,
you
sir.
do it in 10 hours, it will do it in 1 hour. Got it? Okay,
Sir,
like this.
sir, is it mandatory that one person will be engaged in consolidation?
Sir, okay, see here. Okay, what is consolidation, sir? Okay, see, when I say do consolidate, okay, the same work should not be done by others. Understand?
So,
Understand?
sir, one question.
Uh,
As per my understanding, Venkata asked Bharani to perform this
this activity. Okay.
segregation, right?
Uh,
And Bharani asked for the person like 200 people are required, right?
yes, yes, yes.
In the real time scenario, like like
I will come to the real time now, sir. I'll explain now.
application master will ask resource manager, right, sir?
Of course,
To
for resources.
allocate the resources. Okay,
Yes,
sir.
yes. Okay.
Sir,
See, are you comfortable with this current concept, guys? How okay you can achieve a work, okay, with multiple people? Sir, is it a new concept, sir? First of all, okay, I'm explaining from 1 hour. Is it a new concept, okay?
No.
Sir, okay, you want to construct a house, sir. Okay. What will happen, sir?
One contractor
Okay,
is there.
let's say, okay, so let's say Vinod is constructing house right now. Okay, Vinod. Okay.
Yes, sir.
Okay, Vinod is constructing house. Okay, what Vinod will do to construct? Will Vinod do the construction work? No, right?
No.
Vinod will give to a contractor. Sir, no.
Yes, sir.
Okay, so Vinod will give this work to contractor. What contractor will do now? Now contractor will check
Align.
check and say, hey, Vinod sir, okay, yes, okay, so your plan, okay, you will see the plan. Contractor will see the plan and say, okay, sir, Vinod sir, okay, so yes, okay, your plan is good, okay, to complete your house, okay, I need, okay, So 10 workers for, let's say 20 workers. 20, okay. Okay. 5 people for bar bending, steel work,
Yes.
iron or steel work. Okay. So I need, okay. So let's say, okay, 10 people for cement work. I need 10 people, okay. So, okay, I need, okay, 5 people for, okay, wood work. I need 5 people for paint work. I need 5 people for, okay, so electricity work. Okay. Maybe he will tell, okay, so this is the, okay, so to complete this work, okay, this is the minimum requirement for me. Okay. So if you give the money to get these people, okay, I'll complete your house in, okay, 3 months. Yes or no?
Yes, sir.
Okay. So here, okay, when I say 5 people, okay, it doesn't mean that, okay, he will go with 5 people only. 5 people, he will be rotating. Okay, can these 5 people complete the complete work in 1 day?
No.
No, right? Okay, so, but he is saying that, okay, to complete this work, contractor is saying that, okay, to complete this work, okay, so I need these many people. Okay, so please give me money for these many people. I'll complete your house in 3 months.
Yes.
Yes or no? So it means, okay, you have to do some work. You are approaching one maestri, one contractor. So now, first of all, okay, is contractor do the actual work?
No.
Contractor is kind of again management person here. Yes or no?
Yes.
Yes or no? Okay. So this is how, okay, the work will be done. This is not something new, sir. This is not. I'm not teaching you something new in your life. Got it? Okay. So this is the one. Okay. So now let us take the same thing. Okay. So now here, okay, you have a manager, project manager. Okay. Project manager has a project to complete. Okay. What project manager will do? He will get the project and he'll give it to team leader. Okay. And tell, okay, hey team leader. Hey team leader, okay, so this is the project that you are getting. Okay, do one thing. Okay, this is the project document. Go through this project document and tell me how many developers you want, how many support people you want, how many DevOps you want. Yes or no?
Yes, sir.
Okay. So now, okay, what? Okay, so here you will have team leader. Okay. So now team leader will give the estimation. Okay, he will tell that, okay, we have these many modules we have. So to complete these modules, okay, I need, okay, 10 developers. Okay, and okay, 2 admins. He will tell this one. Who will estimate the work?
Team leader only.
See, project manager is just a manager. Okay, so he may not be a technical person, right? Manager means, of course, nowadays, okay, we have technical managers. Okay, but okay, manager doesn't mean he is a technical person.
Yes.
Okay, manager is not a technical person. Okay, so he will take help, okay, of team leader. Team leader is a technical person. He will check, okay, how many modules we have. Okay, so to complete all the modules, how many developers we want, how many admins we want. Okay, so he will tell. So now team leader will go back to project manager and tell that, okay, so project manager, okay, hey manager, okay, this is what I need to complete this project. Okay, if you give me these people, okay, I'll complete in okay 6 months. Okay. But okay, what if project manager say that, okay, no, I'll give only 5 developers, then it will take 12 months. Yes or no?
Yes.
With less
Yes.
people, it will take more months. Yes or no? Is
Yes.
it there in our life? Huh? Yes or no? Suppose, okay, if I put the same example in this, okay, puts example, okay, so main project, main file is nothing but a main project. Okay, so what are the files? Okay, modules in the project is the blocks. Yes or no?
Yes.
Okay. Who is resource manager here? He is nothing but a project manager.
Yes.
Okay. So then here team leader.
Team leader.
Team leader. Okay. Okay. So here developer. Here admins. Yes or no?
Yes, sir.
It means, okay, so I can fit this framework, okay, in any place, okay. In okay, general construction work also we follow the same process. In fruit counting also we follow the same process, okay. And okay, in office also you follow the same process, okay. Now let us implement the same process in Hadoop. Understand? Understand, sir? Let us implement the same process in Hadoop, okay. So first of all, okay, so now, okay, if you want to count, okay, okay, word Hadoop in this file, okay, you should have this place in HDFS. You should have this file in HDFS, okay. So now what I'm doing as a first thing, so I'm copying the sample.txt file into Hadoop, okay. So what is the size of the sample.txt?
250 MB.
250 MB, okay, 250 MB. Okay. So now, okay, if I put 250 MB into this one, okay, so what is the block size? 128 MB. Okay. And what is the block 2 size? 122 MB. Yes or no? Okay. So now block 1 is here 3 copies and block 2 is here 3 copies. Will you agree with me? Okay, think that okay, block 2 is here, 3 copies are here. Any questions till now? Okay, this concept you know, right? Okay, a file will be divided into blocks and stored into different data nodes.
Yes.
Yes or no?
Yes. Yes.
This is a data node. Okay, so in this server, in HN3 machine, in this hard disk, okay, my block 1 is available. In H3N4 server, okay, so in this hard disk, okay, I have block 1 is available, block 1, block 2 is available, block 2. Okay. Till this it is clear. Yes or no? Okay.
Yes.
So now somebody want to know, some XYZ person want to know how many times a word Hadoop repeated in this file. Understand? So what he will do, he will submit a command. Okay, he will tell his requirement. Okay, I want to know how many times a word. Okay? So who is asking this question?
Developer.
Some person is asking this question. Okay.
Client.
So some client here. Yes or no? So immediately, okay, this one, okay. So for this, okay, so he's asking means, okay, will not go and ask, right? He will type some command. Yes or no?
Yes.
Some yan jar, okay, some command, okay. Okay. Immediately, what will happen? Okay. When you run a command here, jar command, okay. You will run a jar command here, okay. When you run the jar command, what will happen, guys?
FSL started background.
FSL, there was something called FSL, right? Okay.
Yes.
In case of HDFS storage layer, it is FSL. Yes or no?
Yes.
But in case of
YARN,
it is okay. Run jar. Okay. Okay. So if you run SDFS command, in the backend of the FSL will start. Yes or no?
yes, sir.
It will contact name node.
Yes.
Okay. But in case of okay, YARN, okay, so in the backend runjar will start. This runjar will contact resource manager. Understood?
No, sir.
Understood? Runjar will contact resource manager. Now what resource manager will do now? Immediately resource manager will tell, hey, okay, fine, okay, so it means okay, so now here okay, think that okay, so Lakshmi is running this command. Okay. Lakshmi is typing this command and okay, he is pressing enter. Once she presses enter, okay, in the backend Ranjar has started. Ranjar has handed over her command to RM. Okay. What RM is doing immediately? First, okay, RM is creating one application ID for her job. Understand? Okay. So okay, Lakshmi, okay, I acknowledge your work, okay, your request, okay. So the acknowledgement number is this one. Okay. So who submitted this job?
Lakshmi.
Lakshmi submitted this job. Okay. Current status is okay, accepted the job. Okay. Immediately Lakshmi will get a message saying that okay, fine. Okay. Ranjar will reply saying that okay, your job is accepted. Okay, and this is your job ID or application ID. Understood? So now, okay, now it is the responsibility of RM to give the reply to Lakshmi. Understand? Understand, sir?
Understand, sir.
Okay. So here, okay, so that is the responsibility of RM to give the reply to Lakshmi. Okay. Now what RM will do? RM has done this one. Okay. Now what RM will do? Can RM do this work?
No.
Okay. See here. Okay. So can I say Lakshmi is a client here?
Yes.
Lakshmi is a client. Okay. She has given a new project. This is the project.
How many times?
How many times a word Hadoop is repeated? Okay. This is the project that Lakshmi has given to RM. Okay. So RM recorded that in his place. Okay. Now RM has a new project, but okay, to do the estimation, who? Okay, can RM do the estimation?
No, sir.
No, sir.
Okay. Project manager cannot do estimation, right?
Yes, yes.
To do the estimation, I need a technical person.
Yes.
Okay, who is the technical person now?
No, no.
Application manager.
Application master here. Who is the team leader here? Who is the team leader? Application master. Okay. So now I need one application master, guys, to come to estimate this project and okay, drive this project. Okay. Now, what is application master here? Application master is a container. Understood, sir? What is the container? Container means
Course and
You are inside
container means okay,
JVM
it's
mode.
a logical construct okay, with a combination of
RAM
RAM and
and
core. Yes or no? Okay. So now, okay. So in Hadoop, okay, we have default size of okay, default size of application master, default size of mapper, default size of reducer. Understood? Understood, sir. Okay. So now, okay. So here application master, mapper, reducer, all these are containers. Okay. All these are containers. Okay. So now what resource manager will do now? Okay. Resource manager will do. Okay. Resource manager will check now here. Okay. I want to launch a container. Okay. The default size of container here is that. Okay. So these are the default sizes, guys. Understand? These are the default size of containers actually. Okay. So now, as and when RM update this one, now immediately RM need a application master to do the estimation. Okay. So immediately what RM will do now to launch application master, okay. What is the size of okay JVM okay container I want? Yes. To launch application master, what is the size of JVM I want?
1 core 2 GB RAM.
Container 1 core 2 GB RAM. Okay. So now it will go and check here. Okay. Who has 1 core 2 GB RAM is okay. Who has 1 core 2 GB RAM? Okay. What is the availability of resources here? In all the machines, okay, do we have 2 free cores? Yes or no?
Yes.
Okay. So in all the machines, okay, we have GB RAM.
Yes.
Yes, right. Okay, it means okay. So in all the machines, okay, I have RAM is available, cores also available. Okay. So now in this scenario, it will parallelly randomly to select one machine. Okay. So let's say it's selected. Okay. It selected this node manager.
Ideally, it will select based on free resources. Yes.
Who has more free resources? It will select
Okay.
here.
Got it. Yeah.
Who has free resources? Okay. Multiple servers are having, okay, say equal number of free resources. Okay, then it will go based on the ping signal. Okay. So here, okay, whoever has sent the last heartbeat. Okay. So recently, whoever has sent the last heartbeat, it will select. It will go based on that. Okay. Now I want, okay, one core. Okay, one core plus 2 GB RAM. Okay. So in all the machines, okay, I have 6 cores. In all the machines I have 26 cores. Okay. Now, okay. So it randomly selected one. It selected NM5. Okay. In this machine. Okay. Now RM is asking Node Manager 5. Hey, Node Manager 5. Okay. Node Manager 5. Okay. You have more resources, right? Okay. Do one thing. You launch a application master here. Okay. What Node Manager 5 is doing? From this available resources, it is launching one application master. It is launching one container. What is the size of this container, guys?
1 core, 2 GB RAM.
1 core and 2 GB RAM. Yes or no? Okay. So when it launch a container 1 core 2 GB RAM, okay, separately, when it bring, okay, 1 core 2 GB RAM separately, okay, immediately, okay, once it created this one, created a container, immediately Node Manager will 5 will update to resource manager saying that, hey, resource manager, you asked me to create one container, application master container here. So from my existing resources, okay, I used 1 core plus 2 GB RAM to create this application master container. Please update your records. Okay. Now immediately what name node will do now? Okay. So S3N7, right? This is the machine S3N7. Okay, which is nothing but, okay, Node Manager 5. Yes or no?
Yes, correct.
Okay. Now it will ask, okay, Node Manager 5. Okay, so it means, okay, now Node Manager will send the information saying that, okay, hey, so from my allocate from total 6 cores to 26 GB RAM, so I have used 1 core plus 2 GB RAM. Okay, immediately it will update 1 core is used, okay, 2 GB RAM is used. Understand? And it will update, okay, number of containers means 1 container here. You understood, sir? As soon as, okay, a container is launched immediately, the table will be updated. Okay, now tell me, after launching this container, how many cores are available here in this machine?
29.
3 cores.
29 free cores.
5. Okay, how many free RAM is, how much free RAM is available?
Total.
24 GB. Yes or no? Okay. So this 1 core 2 GB is used for this application master until it is running. Got it? Got it, sir? Until it is running. Okay. Now what next? What next? Okay. So immediately, okay, now resource manager is updating this information, application master. What is that? Okay. Application master, where application master is launched?
NM5.
NM5. Okay, it is updated here. Okay, what next now? Okay, after launching application master, now RM will forward the whatever Lakshmi has given that request to application master. Okay, so now, okay, now the work. What is the major project here? What is the project given by Lakshmi? Which is the project? Huh? What is the project given by Lakshmi? How many times? Okay, word Hadoop repeated in sample.txt file. This is the one. Okay, so this is the command he has passed. Okay, so Ranger has started, handed out the command to RM. So now RM has got a new project from Lakshmi. Okay, So now RM is updating that project details into its application state store. Now RM is searching for node manager who has more resources to launch application master. Okay, because okay, without application master, okay, can RM do this work? No. Okay, so it identified, okay, this machine is having more resources, and it asked, okay, node manager 5. See here, RM identified this is having more resources, but okay, is RM launching, or okay, is RM telling to node manager 5 and node manager 5 is launching? See here, okay, normally
RM is telling.
RM telling to node
RM
manager.
telling to node manager 5.
exactly, sir, exactly. But okay, normally what we say, sir, you take this scenario, sir. Okay, let's say you got selected for a new job in a company. Okay, yes or no? End of the who will send the offer letter to you?
HR only.
HR. Okay, HR is sending the offer letter, but okay, if I ask you something, who shortlisted you? Will you say HR, or okay, you will say manager name?
Manager.
Manager name. Yes or no? Okay. So if application master who launched you? Okay, application master will tell RM launched me. But actually, what behind process?
NM5.
Behind scenes, okay, RM is instructing NM5, NM5 is launching here. Okay, so RM, okay, even though manager takes the interview, manager will tell HR to send the offer letter. Correct or not? HR will send the offer letter. Manager will not send the offer letter. Okay, in the same way. So if RM want to select, okay, this as a application master, RM is selecting, okay, but it is launching is happening through NM5. Okay, now it launched. Okay, so now what application master will do? So node manager 5 will tell, okay, so we'll launch this one and tell application master, hey, application master, from now onwards you start working with, okay, he is your manager. Understood? Now for application master, okay, who is the manager?
SS manager.
No.
RM is the manager. HR is the manager, or manager is the manager?
Manager is.
Okay, so now from now onwards, application master, okay, will start working with resource manager. Understood? What resource manager will do now? Okay, now, okay, so resource manager will say, okay, hey, application master, okay, so fine, thanks for joining. Okay, so Lakshmi has given this work to me. This is the project. Okay, do one thing. You analyze this project and tell me, okay, tell me how many consolidation people you want, how many segregation people you want. Understood? So now estimation work has come to application master. Correct or not?
Yes.
Okay. Now estimation, okay, work has come to application master. Okay. Now what application master will do now? Okay. What is the work of, okay, what is the project, Lakshmi's project? What is Lakshmi's project?
Word count.
Times.
Count, okay. In which file?
Sample1.txt.
Sample.txt file. Right? So now, first of all, okay, what we need to do? Application master has to understand where is this sample.txt file. Yes or no? Huh? Yes or no, guys?
Yes, sir.
Yes.
So does the application master know where is sample.txt automatically? No, right? Because okay, sample.txt file blocks are stored in different nodes. Okay. So now what application master will do now? Okay, who will have this information? Where sample? Okay, sample.
Name node.
Name node. Okay, now application master will contact name node and ask, okay, hey name node, okay, I got one new project. Okay, so okay, as part of this project, okay, I need to count the Hadoop words, okay, in sample.txt file. So now, can you tell me where is this sample.txt file is available? What name node will do now? Name node will check in the metadata. Yes or no? Yes or no, sir?
Yes, sir.
Yes, sir.
Name node will check in the metadata. So, okay, so now, okay, name node will have a first image and all, right?
So,
What are the different reports that name node will have?
FS image, edit blocks, data node
Okay.
report, block report.
Edits. Okay, so okay, block report and okay, data node information. These are the 4 reports that a name node will have. Okay. So now what name node will do now? Okay, when application master asks name node, so name node will check in the
metadata.
check in its metadata. So no, name node will check in its metadata. First, it will check in the edit log whether it is available or not. So if it is not available, then it will go and check in the FS image. Okay. So finally, it understood that. Okay, fine. Okay, here sample.txt. So which is of BLK 001, BLK 002. This is the information which is available in the edit log. Okay. In the block report, BLK 001 is with whom? Data node 1 to 3. DN1, DN3, okay, DN3, okay, and BLK 002 is with data node 456. Yes or no? Yes or no? This is the information available in the block report. Okay. So now, when application master asks this information, now name node will provide that. Okay, application master. Okay, your sample.txt file is available. Okay, is divided into 2 blocks, BLK 001 and BLK 002. BLK 001 is in data node 1 to 3, and BLK 002 is with the data node 456. Okay, so now it has got the information like, okay, we have 2 blocks, BLK 001, it is in data node DN1, DN2, DN3. Okay, so and block 2 is in DN
4, 5, 6.
5, 6. Okay, now okay, it understood how many blocks it has. Yes or no? Yes or no, guys? Okay, so now the thing is that again, now we clearly know that how many blocks we have and how many segregation people I want. Normally, number of blocks equal to number of segregation people. Yes or no? Yes or no, sir?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so now what it will ask? Okay, so it will ask, now application master will say that okay, fine, I have 2 blocks, right? Okay, so now I want 2 segregation containers, okay, plus 1 consolidation container. Yes or no? This is what the estimation, right?
Yes.
Sir,
What the estimation now?
sir, is it necessary to read 3 replication data also? One data is enough to read, no?
Sorry, sir. Sorry. Okay. So now I have 2 blocks. So it means 2 segregation containers are sufficient and 1 consolidation container is sufficient. Yes or no? Okay. What is the segregation container size? Normally, segregation container is called as a mapper. Yes or no? Segregation work will be done by mapper. Okay. It means so it will say that I want 2 mapper containers. 1. Okay. And consolidation work will be done by. So here. Segregation, consolidation. So segregation work will be done by mapper container and consolidation work will be done by reducer container. Understood? So now it is asking that this is my requirement to complete this job. To whom it is asking? Who is the boss for application master?
Resource manager.
Resource manager. It is asking resource manager. Here, resource manager, I want this is my requirement. See, you gave me a project. Lakshmi gave you a project, and if you pass that project to me, or you send this project to me, to complete this project, I need 2 mapper containers, 1 reduce two map containers and 1 reduce container. Okay, what is the size of map container? 1 core 1 GB. Okay, but end of the day, okay. Now, what is the size of input data, guys?
250 MB.
What is the size of input data? What is the block 1 size?
120.
I need two mappers, right? Okay. How much data mapper 1 will process here?
128.
120.
28 MB.
What is the size of block 1?
128.
100 MB. Okay. So it means, okay, mapper 1 will process, okay, this one. So this is okay. So block 1 is of 128 MB. No. Block 2 of 122 MB. Okay. So now, so I need, okay, to process block 1, I need mapper 1. So no, to process block 2, need mapper 2. So no. Okay. So now what is the size of default size of mapper 1?
41.
GB. What is the default size of mapper 2?
Same. 141.
141 GB. Okay. So each mapper size is, okay, default size 141 GB. Means, okay, now I want, okay, 1 core plus 1 GB RAM to process block 1. I want 1 core plus 1 GB RAM to process block 2. Okay. So now tell me, can I process 120 MB of data inside 1 GB container?
Yes.
Yes, right?
Yes, sir.
Easily, yes. Okay. Can I process 122 MB of data inside 1 GB? Yes.
Yes.
Suppose, okay, if these are bigger than this size, then okay, you may have to change this size. Yes or no? But okay, at this moment, okay, these sizes are sufficient here. Understand? But I would say, okay, 1 GB is more than enough, right?
Yes, sir.
Yes,
Okay.
sir.
But okay, let us go with the default sizes here. Okay, 1 core 1 GB. Okay. So now I want, okay, 2 mappers. Okay. So now, okay, while sending this mappers, okay, it is telling a saying that, okay, hey, I understand that, okay, to process, okay, block 1, I need mapper 1. To process block 2, I need mapper 2. Okay. So, but okay, my block 1 is in this one. So give me any one place. Understand? I want, okay, mapper container, okay, of 1 core 1 GB. Okay. But on any one place here. Do you want to see, because my block 1 is in 3 places. Do I need 3 containers, or if I process only one block, that is sufficient?
One is sufficient, sir.
One is sufficient, right? Sir, okay, let us take this scenario, sir. Okay. In this, okay, Hadoop repeated, okay, 10 times, sir. Okay. So block 1 means, okay, the block 1 is same, right? Same, right? In block 2, okay,
Yes,
Hadoop
same only,
repeated,
sir.
okay, 5
Same.
times. Yeah. It means, okay, when you process this block 1, you will get 10. You process this one also, you will get 10. You will process this one also, you will get 10. Yes or no? If you process all same three blocks, you will get Hadoop 30. Yes or no?
Yes.
Yes or no, sir?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So you should not process all the blocks. Okay. You process any one block. Okay. That will give you, because all 3 are same blocks. Okay. You process any one block. I don't want to process all 3 blocks. If replication is there, doesn't mean that, okay, I will process each and every block. For block 1, 3 copies. Out of 3 copies, you process 1 copy. While processing this copy is failed, okay, you take the second copy and process. Like that, okay, it will work. Okay. So think that, okay, now, okay, what it is doing now? It is asking, okay, give me one mapper 1, possibly on these machines. Yes or no? Yes or no? What the application master is asking? Okay, hey, resource manager, to complete this work, okay, I need 2 mapper containers plus 1 reduce container. Okay, so but these 2 mapper containers also don't give wherever you want. Okay, give me first mapper possibly on 3 nodes. Okay, okay, any one out of these 3 nodes. Okay, give me set mapper 2. Okay, in any one of these 3 nodes. Yes or no? Okay. So now now RM has to give the mapper 1. Okay, where RM will give the mapper 1. Okay. What are the recommended nodes for mapper 1? 1, 2, 3. Now it will check. Okay, 1, 2, 3. Okay, where we have more resources now. It will check the free course and free RAM. Where we have more resources. Huh?
It will select randomly now.
No, all are having same resources, right?
Yes, yes.
Okay. So now then, okay, RM will select a random one. It means, okay, so maybe like, okay, RM may select, okay, node manager 1. Okay. Now RM will tell, hey, okay, application master want okay one mapper container. Okay, you release one mapper container and okay, you create a mapper container here. Immediately, what node manager will do now? What node manager will do? What RM is telling? Okay, so RM is telling node manager one release one container. So it is asking node manager, okay, release one container. Okay, what okay node manager is doing now? It is releasing, okay, so map one container. What is the size of this map one container?
140.
20. Okay, it means okay. So one container is given. Okay, this is created here, and it will tell hey. So for mapper one, who is the boss now? So okay, for team leader, who is the boss?
Other.
Manager. Yes or no? Manager. Okay. Okay. For developer, who is the boss?
Team lead.
Developer means mapper, right?
Yes.
Yes or no? Okay. So while launching this one, node manager one will tell, hey, mapper one, okay, you should work with application master one. He is your boss. Understood? Understood or not, guys? See, when NM5 is launching application master, what NM5 will tell? Application master, who is your boss?
Resource manager.
RM is your boss. Okay. When NM1 is launching this one, okay, it is telling that okay, hey, mapper one, your boss is application master one. Okay. So then, okay, so RM understood that okay, this is out of these three, this is having okay. Randomly it has selected this one. Okay. Now, okay, now for block 2 also we need a mapper 2, right? Where to launch mapper 2? Out of these three. Now we need to check okay 2, 3, 4. Node manager 2, 3, 4. Okay. Node manager 2, 3, 4. Okay. Out of these three, who are having okay. So now okay. So okay. Before that, okay. Once a kit is launched here, immediately it will update to resource manager, right?
Yes.
Huh? Then okay, what resource manager will do? Resource manager will update. Okay. So number of containers. Okay. 1. Number of containers 1. Okay. And allocated cores. Okay. So user cores. How many are user cores? 1. Then how much user RAM? 1. Okay. Now what is free here? What is free here, guys? 5 cores. Out of okay, total okay, see total core 6. Okay, out of that, okay, use this, okay, 1, okay, are in use. In use cores, in use RAM. Understood? In use cores and in use RAM. Okay. So now in use course is how much? 1. On which machine? NM1. Understood? NM1. Okay. User RAM is 1. User RAM also 1 GB. Okay. Fine. Okay. Till this is it is fine. And now coming to the second mapper. Okay. So second mapper I require okay our application master require possibly on any one of these nodes. Okay. So now it will ask okay. So application master is asking the resource manager okay give me one more mapper container possibly on these 3 nodes. Okay. Now it will check NM234. Okay. RM will check here. This is the table to launch a resource base. Okay. It will check NM234. Okay. It is checking 234. Out of these 3, who is having more resources? All are having same resources, right? Yes or no? Okay. So then randomly it will select one. Okay. Let's say randomly it has selected this one. It has selected this one. Understood, sir? No. Okay. Randomly it has selected this one. This is mapper. Sir, no. Okay. Again, okay. So randomly selected means okay. Who will ask to launch? So here RM is telling NM2. Okay. RM is telling NM2 saying that okay, hey NM2. Okay. Application master want okay, one mapper container. So you launch the mapper container in this machine and give it to application master. Okay. So now, okay, as per application master request, both the mappers are launched or not? RM
Yes.
helped to launch the both mappers or not?
Yes.
Yes, right? Okay. So now, okay. So are they having the work? Okay, they are the just new containers, right? They are just created containers, correct or not?
Yes, sir.
They are just created containers. Okay. So now, okay, what application master will do now? Application master will tell, okay, hey, hey, mapper one, okay, you process block one, which is in this machine, which is in this data node. So your input is block one, understood? And the same application master is telling this mapper, okay, your input is block two. Okay. So for you the input is block one, for you the input is block two. Okay. So you process block one and tell me how many times Hadoop repeated, and you process, okay, or you segregate Hadoops, all Hadoop words. And okay, you process block two and segregate all Hadoop words. Understood? So now, okay, the segregation is doing a segregation. Hadoop, Hadoop, Hadoop one. Like this, it's segregated. Okay. So here also, what it has done. Okay. Let's say here, okay, Hadoop repeated. Okay, so only 3 times. Okay. So what is the mapper output here? What is the mapper output?
Four times.
Hadoop one.
Segregation. 4 individual Hadoop words. Yes or no?
Yes.
Sir, in this, okay, what is the output of, okay, this person? Segregated apples. Yes or no? Yes or no? All
Sir.
apples, okay, put separately. Okay. But here it is, okay, Hadoops, okay, 4 Hadoops, okay. He found 4 times Hadoop. Okay. This guy, okay, mapper 2 found 3 times Hadoop. Correct. Okay. So once the work is completed, so now mapper work is complete, segregation is completed or not?
Yes. Yes, sir. Completed.
So segregation is completed here. Okay, mapper 2 also segregation is completed. Okay. Once they complete this segregation, okay, where they will write this output? Okay, they will write in the OS file system. Is it my final output, guys?
No.
Need to consolidate.
Okay, this is only segregated output. Okay, the segregated output will be written to local file system. Understood. The segregated output will be written to local file system. Okay, it has written. Okay, so then the segregated output, okay, output of this mapper will be written to this file system, this OS file system. Okay. So now mapper one has written its output to OS file system, local file system on this machine, and mapper 2 has written its output to local file system of OS disk of, okay, this machine. Okay. Now the work is completed or not? Mapper 1 work, mapper 2 work completed or not?
Yes, completed.
Completed. Okay. Now, so do we need, okay, mapper 1, mapper 2?
No.
Not okay.
Not required. Okay. Now application master will tell resource manager, okay, here resource manager, work is completed for these mappers, release them. Understood? Okay. So I will put that in a separate. So once work is done, okay, once work is done, immediately what, okay, application master will tell, application master will ask RM, okay, so here release this one. So now, okay, again RM will tell node manager one, release this guy. Okay, now this is released. Okay, it is released. Okay. Now when this is released, okay, and again the same way it will tell to release this one also, right? Huh? Yes or no?
Yes, sir.
Okay, so both the mappers are released. Once they are released, okay, immediately they will update, right? What they will update here? Earlier, okay, they updated like, okay, so here, right? So one, right? Okay. So here total 3 containers. Okay. But now what they will update? What they will update, sir? They'll update that. Okay, so now I don't have any containers. Okay, once it is released means okay, from this pool, okay, we have taken 1 GB, 1 core. Now we are releasing it back to pool. Yes or no?
Yes.
So it means okay, so it will tell okay, I don't have any containers, 0, 0. Okay. So user code 0, 0. Okay. User RAM also 0 in my system. Okay. It means at this moment, okay, in my entire cluster, how many containers are running? Only one container. Who is that one container? Application master. Okay. Application master. Okay. So now mapper work is completed. Now, okay, what is the left out work? Reducer work, consolidation work. Yes or no? Okay. Now application master will go and ask, okay, again, resource manager, hey, I want a consolidation person, please allocate. Okay. But in which machine? See, where is my segregated output available? On node manager 1 machine or node manager 2 machine? Yes or no? Okay.
Yes, sir.
Now it will tell, okay,
Yes, sir.
hey, resource manager, since my outputs are available here, segregated outputs are available here. Okay. Preferably you give the reduce container in any one of these two machines. Okay. Now it is checking. Okay. First node and second node, both are having same resources. Okay. So it will tell. Okay. Let's say it is telling again. It is telling RM is telling RM selecting a random node. It is telling okay, node manager 1. Okay. Hey, you launch. Okay. A reducer JVM.
So in any one of the node where
The
where
partial output is available.
yeah.
Segregated output is available.
Okay.
Okay. So reducer 1. What is the size of reducer 1? 1 GB. Okay. It's separated okay. From these resources. It's separated reducer 1. Okay. Then what is available here? Immediately it will update, right? 1 container, 1 core used. Okay. And 1 GB is used. Yes or no? Okay. So it means okay. If I see this table, I will understand at any point of time how many containers are running in my cluster. Got it?
But
Now reducer is started here. Okay. Now for reducer, okay. So now what NM1 will tell, okay, hey reducer, okay, your boss is application master. Yes or no? Okay. Now once it is launched, okay, what application master will do? Now application master tell, okay, hey, reducer, okay, hey, what is the input for reducer now?
Segregate output.
Segregated output. But okay, segregated output is in one place or two places?
two places.
Two places.
Okay. Both segregated outputs are the input for reducer. Understood?
Yes.
Both segregated outputs are the input for reducer. Okay. Now, okay, so what it will take, okay, if you take the first reducer output, okay, this is the first reducer output, okay, and this is the second reducer output. So second mapper output. Yes or no? Okay. So mapper 1 output. Okay. And this is map 2 output. Yes or no? Now it will take, okay, these outputs are the input for reducer, correct or not? Okay. Now reducer will generate the output of, okay, Hadoop 7 output. Is
But
that?
how will it take mapper to this thing from second name node?
It will go and copy, sir. It will go and get it.
Okay.
It will just copy. Do the SCP. Reducer will contact this machine, okay, local file system. This machine, local file system, and get this segregated output, and put it here. Okay. Take it like as input. Okay. Now do the final output. Give the final output. What is the final output? Hadoop 7. Hadoop 7 is the final output. Okay. So now, if you ask reducer to print this output on the screen, it will print it on the screen. Understood? Understood? If you ask this reducer to print this output on the screen, it will print it on the screen. But if you ask this reducer to save this output in a separate file, understood? It will be put into a separate file, okay, and stored into SDFS again. Again, when it is storing its output, okay, again, okay, the same replication factor, blocks, all the concepts will come into picture. Suppose, okay, if you tell reducer to print output on the screen, directly it will print it on the screen. Okay, but if you tell reducer to save this output, okay, in a file and store it on SDFS, then okay, reducer will contact name node to store this output into a file. Understood, guys? Understood or not?
Sir, how reducer is knowing where the segregate output is? Application master is saying, or
Application master is given that information, right?
okay.
Because okay, see here, when mapper is okay writing its output, okay, mapper is updating application master, saying that okay, application master, okay, you asked me to segregate the Hadoop code in this block. I did this one. Okay, this is the output I got. Okay, this is the segregated output I got. I stored it here. Please update your records. So it means okay. So mapper will update to application master. Then only application master will release this mapper. Understood? So application master has the path of both outputs. Understand? Application master has got the picture of okay, where okay, mapper one output is stored, where mapper two output is stored. Got it?
Yes, sir.
Got it or any questions?
But reducer will contact directly this
Of course, yes.
output.
Local file system, yes. Output
No need to contact the application manager.
nothing. No, see here, application master will tell, right? Will tell reducer, right? Otherwise, okay, how reducer will understand? Okay, this is the place I have segregated
application
output.
manager will tell to the path to reducer.
Application master will tell reducer when reducer one is launched. Application master will tell a reducer, okay, see, you need to consolidate the work. Okay, for you the input is segregated output. Okay, segregated output is available here and here. You go and get the segregated output. So that is your segregated output is input for you. Correct?
Yes.
And generate the output and okay, and print it on the screen. If application master say print it on the screen, it will print it on the screen. Okay, but if application master say reducer, okay, store it in a file and okay, put it in SDFS. Again, reducer will contact name node and okay, ask name node to help in writing the file. You know what will happen? Okay, if somebody goes to name node, okay, to write a file, then FSL will start, right? Yes
So
or no?
the input file is, you said the input file should be in HDFS, right?
Yes, sir. Input file should be in SDFS.
So can't we submit the yarn job if the file is in OS storage?
No.
So then how the after segregation the file is stored in OS storage? Why the output segregation output is not stored in HDFS?
Okay, I will tell you, sir. Okay, is this my final output or okay, it's an intermediate output?
Intermediate only.
Why I want intermediate output? Tell me. Okay, so now I have not completed. Okay, so now reducer. Okay, think that okay, the application master is telling that reducer to print it on the screen. Okay, let's say it printed the output. Okay, Hadoop repeated 7 times. It printed on the screen. The output is generated, right? Yes or no?
Yes, sir.
Okay. Once output is generated, now reducer will go and tell application master, hey application master, okay, as per your instructions, okay, I took both the segregated outputs and okay, consolidated and printed the output on the screen. My work is done. Yes or no?
Yes, sir.
Okay. Now what application master will do now? Application master will send, okay, tell resource manager, okay, resource manager, okay, so reducer is telling that his work is completed. Okay, release that guy. Understood? Okay. Now application master is telling resource manager release this guy. Okay. Now resource manager will say, okay, hey, node manager one, release this guy. Okay. So now this guy is completely released. Understood?
Sir, application master will contact node manager or resource manager to launch the container.
Sir, application master is contacting resource manager only.
The resource manager will guide the
Will guide the node manager to launch.
the point of contact with the resource manager only for
Yes, sir.
application master.
Yes, sir. So team leader is asking resource manager, manager is telling okay, HR to release the offer letter. Yes or no?
Yes, sir. Yes.
Will manager release the offer letter?
No, no,
So
no.
here,
HR will take.
here okay, node manager is kind of HR.
Yes, sir.
Yes or no? In our example, okay, in our previous example, okay. So here, who is node manager? HR. So whatever manager will say, if manager says send the offer letter, okay, he will send the offer letter. If manager says terminate this guy, she will terminate this guy. Yes or no?
Yes, sir.
So HR work is just to listen manager. Correct or not?
Yes, sir.
So this is what the same thing it is doing now. Okay. So now reducer also released, but a reducer printed output on the screen. Okay, reducer work is completed. Application master asked resource manager to release reducer also. Now, okay, I have the total project is completed or not? Whatever Lakshmi has given, okay, she got her output or not?
Yes, sir.
She got her output printed on the screen. Correct or not?
Yes.
Okay. So now project is completed. Okay, when project is completed, okay, do we need this application master? Do we need team leader?
Not required.
Not required. Okay, so now application master will go and tell resource manager, hey resource manager, so total project is completed. Okay, so total project is completed. Okay, what RM will tell? Okay, application master, do the cleanup now. Okay, good, very good. Okay, do the cleanup. What do you mean of cleanup here? What to clean now? What is left out here?
Releasing container.
No, releasing content is already done, right? What to clean up here? There is segregated output already available.
Segregated output.
Segregated output is here. Okay. So now
Segregated data.
application master will clean the segregated output because it knows the path, right?
Yeah, he knows the path.
So you will go and clean up all these things. Okay. Then okay. So then cleaning is done. Now RM will tell. Okay. So thank you, application master. Thanks, team leader. Okay, project is successfully completed. Okay, we will go. I will release you. Okay. If any new project comes, okay, I will take you again. Okay. So now RM will tell node manager release this guy also. So this guy also released now.
Sir, the thing is, so if the file is in local file system, we cannot submit the yarn job.
Yes, sir. Okay. Now, okay, this is okay. So all this just okay, the status is running. Now the status will be changed to succeeded. Understood. Understood, sir. At the end, okay, what we have on the screen, okay, we have output. Okay, is there any change in the block numbers? Blocks they'll be there only, right? Yes or no?
Yes, sir.
They'll be there only.
Yes.
Okay, so once it is changed, okay, then okay, it will tell the Ranjar. Okay, so Ranjar also closed. Okay, and Lakshmi has got the output. Everything is closed now. Yes or no?
The client will log into the edge node, sir, as a user.
Of course, yes. The user, the client will log into edge node. Okay, now on the edge node, okay, you got the output saying that okay, Hadoop is 7. It printed on the edge node screen. In your put.
Sir, application master can directly contact name node
Of course, yes.
because it's a yarn layer that is the storage layer.
But still, okay, they are all in the same place, right?
Okay.
Yes or no? Sir, okay,
Is
see
there
here.
any
Okay, so now, okay, RM, will it talk to name node?
No.
Name node? No. Yes or no? RM to then no. RM to DN? No. Okay? Yes or no?
Yes.
Okay. So here, okay, so I will put RM, NM, NN, DN also I'll put here. NN, DN. Okay. RM name node, will they talk each other? Resource manager, node manager?
No.
No. Resource manager, data node?
No.
Node manager, name node? No. Okay. Node manager, data node? No. Even though they work in the same place, okay, they will not talk to each other. Okay. But the application master to name node? Yes. Okay. Application, okay. Mapper to name node? No. Okay. Reducer to name node? Yes or no? Will application master talk to name node? Yes. Will mapper talk to name node? No. Okay. Will mapper talk to data node? Yes. Okay. Will application master talk to data node? No. Will reducer talk to data node? Yes. Understood. Understood or any questions, guys?
Sir, what if the file is in local file system if I want to submit the yarn job?
No, sir. Okay. No.
Then what is the
You
alternative?
can do it, sir. You can do it. Okay. But okay. It is like only one machine. Yes or no? If your file is in local file system, yes. Okay. Your yarn will still run your job. Okay. But it is like a standalone, right? Why we are going to HDFS? Because okay, when you go to HDFS, okay, all your blocks will be your file will be divided into blocks, and blocks will be scattered across different data nodes.
So
Yes, sir.
then you have to move the file from local file system to HDFS.
Yes.
Right.
Understood, sir.
Yes, sir.
Okay.
The final output is stored in HDFS only.
Sir, okay, it depends, sir. Okay. You can tell reducer to print output on the screen, or okay, you can tell reducer output to print on store on the. Okay. So now if you tell reducer output to print on the screen, it will print like this. Okay. This is print on the screen. It will print like this. Okay. If you say no, I don't want to print on the screen. Okay. I want to store in HDFS. Then what will happen? Okay. The name. Okay. Output.txt. Output.txt. Okay. So now output.txt will be available here. So here. So you have output.txt. More file txt, which has only BLK003. Okay. Turn now. Turn, sir. One more file, right?
Yes, sir. That is output file. Okay.
Yeah.
Sir, in general, without giving any path, it will store on HDFS or
You will give some paths, sir. Okay. So some path, LCFS path. Okay. Again, okay. So you will have. Okay. So BLK003, which is in data node 5, comma, data node, okay, 3, comma, data node 4, comma, data node 5. Okay. It means, okay, BLK003, okay, is available here.
with replication also.
Of course, yes, right. Okay.
Output.
Whatever you write on HDFS, that will have replication, right?
Okay.
Check BLK003, what you will have? Content.
Only Hadoop 7. Hadoop equal to 7. Right.
You are asked to, you ask your application master to store the output, it will store like this. Okay, but if you ask, okay, to store, print the output on the screen, it will print the output on the screen. It will not store anything in the HDFS.
Okay.
Understood? Or any questions? Sir, I will share this today's recording to all of you in the group. Okay, please go through this recording. Okay, see, storage layer is very easy in Hadoop. Okay, processing layer is the one. Okay, you need to understand properly how. Okay, how your system is okay launching the. See here. Okay, what you understood based on the requirement. Okay, it is launching the application master. Based on the requirement, it is launching mappers. Based on the requirements, it is launching reducers. Based on the requirements, it is releasing application master, releasing mapper, releasing reducer. Yes or no? So here, every machine, every node manager is having pool of resources. Correct?
Yes.
A pool of cores and RAM. Okay. From this pool, based on the requirement, it is I'm taking okay a set of resources, using it and releasing it back. Yes or no?
Yes.
Okay. But end of the day, okay, if no resources are running, no containers are running, then okay, your pool is with full capacity, completely available. Yes or no? Yes or no or not? Yes. Here, okay. In the first example, okay, here application master launched. Okay. Then okay, we launched mapper 1, mapper 2.